Inshallah, Bismillah ar-Rahman ar-Rahim. Inshallah, today, inshallah, we're going to continue the discussion regarding the Ethernet standards, and today we'll talk about switches. Uh, so switches, as we all know, is a layer 2 device, which means that it has a data link layer and it performs its functionality from the data link layer. So the first topic we'll talk about today is the basic operation of a switch. Basically, the switch is, as we said, it's a layer 2 device which has multiple ports. So these ports, they have actually numbers. So it's port 1, 2, 3, and so on. And there are some output ports as well. Okay, and the switch has like a switch fabric, which we will talk about. And the switch is actually used to read the frame that's coming on any of these ports, and it reads the destination and the source addresses from the frame, and based on that, it forwards the frame to one or more of these output ports. So this is the basic functionality of the switch. So based on the destination physical address, destination MAC address, and the destination source address, it can forward the frame to one or more of the output ports. Of course, that's straightforward, but again, similar to ARP, so there are some similarities with ARP. So the switch also knows or builds the learning or the knowledge about what destination is physically connected with which output port. It does that gradually. So when it first starts, it needs to know that destination MAC address XYZ is in fact connected on port 30. Okay. The switch, by the way, could have 48 input and output ports, or sometimes more than that. Enterprise switches may have more than 48 input and output ports. So, so again, the switch needs to gradually build the knowledge about what destination MAC address connected to which output port based on a certain procedure. So again, similar to ARP, the switch also has what we call, we don't call it ARP table in that case, or ARP cache, we call it MAC table. Okay. So the switch has a MAC table inside it. And then in this MAC table, it has a MAC address and output ports, port number, يعني. Okay, so it needs to know that this physical address is actually physically connected on this output port. So how does it do that? How does it do that? So the procedure is, again, there are some similarities with ARP, but there are some differences that we need to be careful about. So the first step that the switch does is that it actually checks the destination and source address. This is the minimum number of fields that any switch would read, and we'll talk about why do we need to read the source MAC address as well. So the switch will read the destination and the source from the frame. Okay. So tab number 2, it checks the destination MAC in the MAC table. Okay, does it actually exist in the MAC table? Does this MAC address exist in the MAC table? The destination MAC address exists in the MAC table? If the answer is yes, and I have the MAC address in the MAC table, then my job is almost done. All I need to know is to get the output port, and based on that, I will actually forward the frame from a specific input port to that output port, and my job is done. Okay, so that's it. But when the switch first starts, again, similar to a child that's first born, it doesn't actually know anything. It doesn't know which MAC address connected to. In other words, the MAC table is empty. So the answer for the question like this will potentially be no, it does not exist in the MAC table. Okay, so in that case, for number 3, based on the fact that the answer is no, the check will perform a certain operation. What is this operation, Bachelor? What is this operation exactly? Any guess? ناصر عبد الوهاب تفضل. Okay, flood frame to all ايه؟ connected ports. Is that it? أيوة, except the port it came from. تمام يا نصر, تمام. That's a perfect definition. So we flood. I don't want anyone to say that the switch broadcast. Never ever say the switch broadcast. Broadcast is a frame that has a destination address, all Fs. Okay, that's broadcast. Switch will not broadcast. The switch will flood, and flooding is the operation that happens if the switch cannot find the unicast MAC address in the MAC table. واضح? This is very important. So there is a big difference between flooding operation and broadcast operation. ماشي? So the switch will flood the frame to all connected ports except the one it came from. That's a basic and rule that has no exceptions, as we will see in the activity in a minute. Number 4, there is a very important operation that happens, which is similar to ARP, which contributes to accumulating knowledge. Okay, what is that? What is that step? Is my job done just by flooding the frame to all ports, to all connected ports, or what do I have to do other than this? حسام تفضل. لا لا no 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 no. Do not make this assumption يا حسام. I didn't tell you that. The destination will reply back, acknowledge. This is based on the protocol. We didn't talk about specific protocol now. This is a big mistake that some students they fall into. They assume that the destination will reply back. We didn't say that. That depends on the protocol that's used. The switch has nothing to do with this. But what will happen here is a very important step. The switch stores source MAC on port I, which means that, remember, I don't know where the destination is connected to, but what I really know for a fact is that this frame and the MAC address of the source is stored in the frame. This frame actually came through port 1, right? That I know for a fact. So in that case, I will put the source MAC and port 1. Okay, this is a very, very important step because this step contributes to accumulating knowledge. So next time, if the MAC address of the source becomes a destination in a future frame, okay, and that depends on other things, it's outside my scope. But if it happens that this MAC address becomes a destination MAC address in another frame, okay, Next time I will look at this MAC address and I will figure out that it's connected on port 1. So I don't have to flood, I don't have to do anything. I can just right away forward to port 1. Okay, so this step is very important and contributes to accumulating knowledge. Okay, so any question about this? So this is the first topic. It talks about the basic operation of a switch. Right. Second topic is the switch modes of operation. Okay. In fact, the switch, there is a a very important feature in the switch that allows any switch to change the mode of operation on any port. It makes any port input or output, or it makes any port full duplex or half duplex. It makes any port to work in one of the modes of operation that we will talk about. What is this feature? What is this feature? So the switch has a specific feature. It has a formal name that allows any switch to change the mode of operation on any port. It makes any port customizable, okay, based on the context of the network. Some ports might be input, some ports might be output, some ports might be full duplex, half duplex, things like that. What is that feature? حد عارف؟ It's called auto MDEX. Okay, this feature is a very important feature in switches, in recent switches, especially modern switches, which allows the switch to customize the input and output ports and change the modes of operation. So what are these modes of operation بقى? So the first mode of operation is what we call store and forward. Another mode of operation is called cut through. So what is the difference between the two يا شباب؟ حد عارف؟ What is the difference between the two? Any raise of hand? حسام يحيى اتفضل. It has يعني it has the entire frame. It stores the entire frame. Okay طيب ماشي. Cut through. Does not have to. What does it read? Cut through. What does it read? ايه تاني معلش. يحيى انت لسه معايا؟ اتفضل. What does it read? The cut through. What does it read? It doesn't read the frame at all ولا it does ولا ايه بالظبط؟ Does not store the entire frame. Okay, what does it do بقى؟ لا مش إجابة كاملة دي يا حسام. مش إجابة كاملة. The store and forward stores the switch will store the entire frame inside the switch. Okay, and then through hardware بقى, it has to read all the entire frame. Okay, so it reads the destination and the source, and it reads the actual data, and it goes all the way to the last field, which is called the frame check sequence. Okay, and then it uses the frame check sequence to make sure that the frame has no error. Okay, and then if the frame has no error, which is a step here, there is actually a 3 dash here, check for error. This happens only for the case of store and forward. Okay, So in the store and forward, the switch will store the entire frame, will check the frame content against the frame check sequence, and only if the frame is completely correct, then it checks the destination address and it forwards or it floods the frame to all the connected ports, as we said. Okay? Cut through doesn't do that. Cut through does not store the entire frame. It actually reads only it performs the functionality, the minimum functionality. So it reads the destination address only. And that's why we said the destination address is the first field, because the switch reads the destination address and then it forwards the frame very, very fast without even checking for error. Okay? So this has error checking and this has no error checking. This is very fast, of course, and this is a slow, of course, because of the fact that I have to store the entire frame and then I have to take my time to check for errors and so on. تمام كده؟ So the question is now, is speed always good? Is speed always good? Well, the cut through seems to be very fast and it seems to be attractive, right? Because I don't have to check for errors. But in fact, not checking for errors and being fast is not always good. Why? Because if the channel or the medium itself has high probability of errors, chances are I will forward many frames on the medium, and the medium actually has some probability of error, in which case I'm forwarding garbage, really. The switch will keep forwarding frames in error. What does that cause, or what this entails, is the fact that many nodes, when they receive the incomplete frames or the error frames, they will have to discard it, and we'll keep doing this, and I keep wasting the time of the destination nodes by having to check for errors, and the frame is actually incomplete or it has some errors. So in other words, speed is not always good. And imagine this situation in real life. If you have cars coming to the intersection, okay, very fast, without checking for anything, what can potentially happen? Collision. So they will collide, and you will have lots of accidents, right? So when does speed make sense? If in one direction, مثلا, the roundabout in one direction is empty, and in that case I can just pass by without having to check for anything, so I will go very fast. So if the traffic is low, the probability of collision is low, so being fast is good. But when there is crowded cars coming to the intersection very fast, the probability of collision becomes very high. And in that case, the cut through is not always good. That's why cut through has two sub modes of operation. حد عارف ال two modes of operations دول؟ Cut through has two sub modes of operation. What are these? محمد زيهان تفضل. Fast forwarding and fragment free. What is the difference بقى? So it reads destination plus source only. It doesn't read anything else. Fragment free. Okay, it reads بقى first 64 bytes. Okay. So why بقى? Why? You don't have to do this, Muhammad. Your answer is correct. So fast forward is what we say, that the switch will do the minimum, will read only the destination and the source address, and then it forwards the frame right away without checking for errors. Fragment free also does not check for errors, but it actually reads the first 64 bytes. Why بقى? Why especially 64 bytes? Remember that when we talked 2 lectures back, that the minimum size of the frame is in fact 46 bytes, And when we add the 802.2 header to the data, it becomes 64 bytes, and this is the minimum. Remember we said that? So now we know why we need bقى 64. Because in fact, experimentally, they found that if there is any probability of collision, it happens when the source tries to send the first 64 bytes. So if the source, if the switch waits to read 64 bytes without detecting any collision, chances are, if this frame is forwarded, it will not have collision. Okay, so fragment free tries to address the trade-off or the compromise between fast forwarding and store and forward. Fast forwarding is extremely fast, but the probability of collision for fast forwarding becomes really high. The probability of collision becomes really high because it forwards everything extremely fast. Whereas for fragment free, it tries to be somewhere in between. I will read the first 64 bytes so that if there is any probability of collision, okay, it will happen within the first 64 bytes. And someone might say, might not be able to visualize this. So I will explain it very, very fast. Okay, if you don't get the idea, it's fine, because we will explain it again in network 2. We'll explain it in details. So if you have a source, and you have a node at the end of the, remember we're talking about wired, right? Switches here for Ethernet, they support wired networks, not wireless. So we have a cable. The maximum size of this cable for UTP, by the way, is typically, as we said before, 100 meters, right? So experimentally, what they have found is that if you send a frame, if the source tries to send a frame, this frame will be converted to a signal, and then the signal will start to propagate over the wired medium, right? So they found that if the frame is actually less than 64, the source will finish sending the frame, and the frame, because it's very small, it will not occupy the entire line. Okay, it will not occupy the entire line. So there will be some empty part of the medium that has no signal. Okay, so what is the problem with this? The problem with this is that this node on the other hand side here, okay, does not listen to the frame that the source is trying to send. And even the source finished sending the frame, and the other node on the other line cannot feel it because the frame is not occupying the other line. So what can potentially happen? This node will try to send a frame on this from this side, and the collision will happen with very high probability. Okay. However, and when the collision happens, by the way, the source does not even know that there is a collision happening because the source finished sending the frame. The other scenario is that if the frame is more than 64 bytes, chances are this frame will occupy the entire line before the source finishes sending the frame. And in fact, they found that this is good. Why? Because this means that everyone on the line will know that the source is trying to send. In which case, everyone on the line, they will abstain from transmission, in which case the probability of collision becomes low. واضح يا شباب؟ So fragment free tries to address the trade-off between extreme speed, okay, and the possibility of collision. So by reading this 64, the first 64 bytes of the frame. واضح كده؟ So these are the modes of operation, and the feature auto-MDEX, which allows the switch to switch each port to a specific mode of operation as it wants. Okay? ماشي كده؟ Any questions so far? So that's topic number 2. Topic number 3, very fast. We talk about ايه بقى? Number 3 here. Talk about switch architectures. By switch architectures here, the hardware architecture بقى, this is the computer architecture. So the switch has two major architectures. One, we call it port based. In port based, the port, sorry, the switch has the input ports in the form of a queue. So each input port is in fact in a form of a queue. So at each input port, I have a queue. And as we all know, queues are first in, first out. So when a frame comes on a port, these frames, they will line up in the queue like this. Okay, so they will line up in the queue like this. Okay, first in, first out. So they come for the first one. The switch will use one of the modes of operation to know to which output port it should forward this frame to. So this frame, for example, has an output port which is connected on port, let's say 1, 2, 3, 4, 5. So it's connected on port 3. Okay. So the destination address, if I look up the MAC table, the destination address is connected on port 3. So I should actually forward it to port 3, right? And this queue is first in, first out. So that's good. There is a very important phenomena that happens here, which is kind of interesting. That happens in port-based switch architecture. By the way, here we call it switch fabric. This is what switch fabric. Switch fabric بقى is the actual hardware which allows the switch to forward from any input port to any output port. It's like a hardware circuit that makes the frame go to one output port based on طبعا some control signals that the switch will have to set by checking the destination address. So this is the switch fabric. It's the hardware chip on the switch that performs the actual forwarding. A very interesting phenomenon that happened here, if a frame happens to go to port 3, this port will have to be declared busy, okay, throughout the transmission. And the frame can get as big as 1500 bytes, which means that this port may stay busy, let's say, for 3 milliseconds. Okay? So what might happen here is that another frame here is also waiting to go to port 3. Okay? While this port is busy, the frame will have to stay in a wait state. Okay, this frame will have to wait for 3 milliseconds. Okay, so that makes sense because it needs to go to the same port, and I cannot do that. The switch cannot do that because the switch cannot forward 2 frames to the same port. That makes sense. صح كده? So this frame has to wait. When this frame waits, the problem is not actually for this frame waiting. The problem is that all the other frames behind that frame are blocked. Okay? Are blocked. So imagine if that particular frame, wants to go to port 6. This frame wants to go to port 7. Okay? These ports are not busy. But the problem is that because of the queue, and the queue is first in, first out, the first frame, which is the head of the line, blocked all the frames behind it because it wants to go to a particular output port that's currently busy. This situation is very similar to the fact that imagine if you are going to a bank, okay, and the bank has multiple doors, okay? So each door will have a big lineup of people, and then we serve the head of the line by asking this person, where do you want to go to? He would say, I want to go to the teller. I want to go to customer service. I want to go to finance department. I want to go to this. I want to go to that. Okay? So if the head of the line says, okay, I want to go to the teller, but the teller is busy, so he will have to wait. The problem is not for him waiting. because he's waiting makes sense. The problem is people behind him are blocked because of him. واضح كده يا شباب؟ So that's an example from real life that resembles that scenario. So this phenomenon is called ايه بقى؟ head of line blocking. So this phenomenon exists in any hardware architecture that uses queues because of the fact that queues are first in, first out. And if the head of the line is actually waiting for a specific service, this head of the line is blocking everyone behind it. ماشي? So port-based switch architectures, they suffer from head of line blocking, and that's the scenario to explain head of line blocking. So to solve that problem, there is another architecture which we call it shared memory architecture. In shared memory architecture we don't have queues. What we have is that the switch fabric itself, okay, it has built-in RAM. Okay, as we all know, RAM is random access memory. So there is no first in, first out. It's not a queue. So anyone can write to the RAM. Anyone can read from a RAM. Okay, even you can have concurrent reads and concurrent writes because you can access any part of the RAM at any point of time. As long as two nodes they are writing to a different location, you can actually read from the same location concurrently. Okay, so RAMs they solve the problem of head of line block, and this is in real life again from our example. Imagine instead of having 2 gates or 3 gates in the bank and everyone is lining up in the gate, imagine if the bank allows people to get in and they all stay in a shared area. They all stay in a shared area. And then anyone can go to the service at the teller or the service at the customer service, okay, from that shared area. So anyone in the shared area can go with any specific order depending on whether the teller is free or not, or whether the customer service is free or not. So in that case, the RAM or the shared memory architecture is more efficient. Okay, in terms of it doesn't have the head of line blocking, and you can read and write concurrently, which is good. The only pitfall or the only problem with the shared memory is that this RAM is very expensive. Okay, this RAM is very expensive, as we can imagine. Queues are very cheap, so this switch architecture is actually much more expensive. So the switches that use shared memory architecture are usually much more expensive compared to the port-based. So that's these are the topics that we want to discuss today. We discussed 3 topics: the basic operation of the switch, the modes of operation, including store and forward and cut through, and then the switch architecture, which includes port-based and shared memory architectures. So this activity here very quickly talks about a scenario where we want to send that frame, the switch received that frame, okay, and this frame has a destination address 0F and the source address 0E, okay. This is the frame that's coming. So this frame is coming on which port? أي حد عنده فكرة؟ This frame is coming on which port? Maximize كده the ports. This frame is coming on which port? أي حد عارف؟ FA9, yes, FA9. Okay, where did I get this from? From the source address. Source address is 0E, and I know 0E here is connected on port FA9, right? Type. So that's good. So the frame is receiving that particular, the switch is receiving that frame on port FA9, okay? And the frame wants to send this to a destination 0F. Where is this destination connected to? Also FA9, here. That's a very interesting situation, bad. Okay. Type. So we need to answer two questions. The first question is, where will the switch forward the frame? Where will the switch forward the frame? So in order to answer this question, we have to do the procedure that we discussed before. So we need to check the destination address. Check this destination address in the MAC table. Does it exist in the MAC table? It doesn't, right? So we need to perform flooding, and flooding is based on the fact that the switch will forward the frame to all connected ports except the one it came from. Okay, so will the switch forward the frame to port FA1? محمد سعد البدر. محمد البدر. محمد البدر, do you have the are you there? محمد البدر, are you there? طيب, let's let's take the attendance now, يا شباب. Let's take the attendance now. I'll give you 5 minutes to take the attendance, okay? I just want to make sure that people are connected to the class and not doing anything else on the side. So you have 5 minutes to check in. Type, where will they switch forward the frame? Does it forward it, or will it forward it on port FA1? This port is a connected port, and it's not the port that the frame came through, okay? So it will forward the frame to port FA1, okay? Will it forward it to FA2? Badr Salama, will it forward it to FA2? Will it forward it to FA2, Badr? اوكي, نكتب اسم بدر كمان, ماشي. Okay, so I hope these people يعني will see the attendance after the lecture. Okay, so Marwan Shahata, will it forward to FA2? Marwan? No. تمام. Why? Because it's not connected. تمام Marwan, ماشي. For FA3 is connected, and it's not the port where the frame came through. So FA3, yes. Will it forward to FA4? FA4 is not connected, so it will not forward to FA4. FA5, yes. FA6, no. FA7, yes. FA9? FA9, yes or no? No. تمام. Okay, yes. Okay, so it will not forward it to FA9. Okay. طيب. So, okay, so that's interesting now, because in fact, 0F is in fact connected on FA9. So how come we don't forward it to FA9? And actually there is another interesting question here. We forwarded the frame to FA3, even though from the MAC table we know that FA3 has 0B, and 0B is not 0F. So why do we have to waste our time and forward it to FA3? So these are two questions. Okay, so the first question is easy. The rule is clear. We flood the frame to all connected ports except the one it came from. That's a very basic rule, and it applies all the time. Will the frame in fact go to the destination 0F? The answer is yes. Why or how? Because here we are going through a hub, okay? And the hub, what it does is that it replicates everything from the physical layer, okay, on all ports. So the frame already went to 0F. I don't have to forward it to port 9 in order to go to 0F. The frame already went to 0F, okay? Type. The other question is, why do we have to forward the frame to port 3 even though the MAC table clearly states that port 3 has 0B? And again, this is a very interesting point. Actually, I got this very smart question from one of the students before, and he asked me this question. And this is a very, very nice question. I would have hoped someone would ask this question. So the reason that the switch blindly sends the frame to the port, even if it knows that the destination connected to that port is different, the reason is that just the fact that this port has 0B, it doesn't mean that it does not have other nodes connected to the same port. Okay? Remember, each port can have more than one node connected to it. And we have this, we have the perfect example. Node 9 has 2 nodes connected to it, and it could be 3, could be 4. So that's why here, in some places in the MAC table, I could have actually more than one node connected. So just the fact that I have 0B connected to port 3, it doesn't mean that I don't have other nodes connected to port 3. So maybe this is 0B, and this is in fact 0F. I don't know. The switch doesn't know. Okay? The switch doesn't know, and that's why the switch has to flood the frame to all connected ports except the one it came from, and this is a rule that applies all the time. Type. The second question here, when the switch forwards the frame, which statements are true? The switch adds the source MAC address to the MAC table. Is that true or false? هو ليه التفاعل مش True, yes. Okay. Frame is a broadcast frame and will be forwarded to all ports. Huh? Is that true or false? Why بقى? It's the frame would be a yes. لا خد بالك. The frame is a broadcast frame. What does that mean? This means if the frame is a broadcast frame, then the destination address is all F. That's a broadcast frame. Okay? But is the destination address all F? No, the destination address is 0F. It's not all Fs. So it's not a broadcast frame أصلا. Okay? طيب, the frame is a unicast frame and will be sent to a specific port only. That's also not true because, yes, it is a unicast frame, but it will not be sent to a specific port only, right? Why, Muhammad? Because it is a unicast frame, صح. But it will not be sent to a specific port only because it does not exist in the MAC table. If it does not exist in the MAC table, it will be flooded. And this is actually this one. Frame is a unicast frame and will be flooded to all ports. Okay? So the frame is a unicast frame, but because the destination address does not exist in the MAC table, it will be flooded to all connected ports except the one it came from. And frame is a unicast, but it will be dropped. Of course, no, it will not be dropped. It will be sent or flooded to all ports. Okay, شباب, any questions here? طيب, very quickly بقى, the modes of operation. The modes of operation here, we need to match the definition on the left-hand side with the modes of operation. So the first one is it buffers frames until the full frame has been received by the switch. This is store and forward or cut through. Store and forward. تمام. Okay. It checks the frame for errors before releasing it out of its switch port. This is also a store and forward. We said that a store and forward will check for errors. Type. No error checking on frames is performed by the switch. This is clearly cut through. تمام. طيب. Number 4 بقى is a bit tricky بقى. It's a great method to use to conserve bandwidth on your network. This is a very يعني ايه vague statement الحقيقة. Which of these two modes of operation will conserve bandwidth? يعني ايه conserve bandwidth؟ يعني ايه conserve bandwidth؟ يعني ايه conserve bandwidth؟ The meaning of the word conserve bandwidth is that you have a specific bandwidth, so you are sending frames within that bandwidth very efficiently, so you are utilizing that bandwidth without having any errors. This means two things. This means that you are sending the frames as fast as possible, but without errors. So you are sending the frames as fast as possible. In order to conserve bandwidth, you want to utilize the bandwidth efficiently. So if you have a roundabout, you want to utilize that roundabout very, very efficiently. So if you have a group of cars, you want this group of cars to pass this roundabout very efficiently and very fast, so that you utilize the roundabout very efficiently, but also without errors. So that's tricky, because in fact this statement is not complete. Okay, so I have to add something to this link in order to make this statement يعني complete or correct, or to eliminate any vagueness. When I have to say when the link probability of error is, okay, when the probability of يعني when the link probability of error is high, okay, this means that if you send any frame on the link, there is a high chance in this probability, this frame will be sent in error. Okay, so in that case, it is better to actually check for errors so that you don't waste the bandwidth and forward frames in error. صح? So when the link probability of error is high, in fact, it's better to check for errors. Okay? But if the link probability of error is low, it's better to send things fast so that you can conserve and utilize the bandwidth efficiently. So this statement is actually vague, because conserving bandwidth here, it means two things. It means you are sending fast, but without errors. And these are two conflicting objectives. So you have to give me another piece of information that clears that confusion. So I have to tell you when the link probability of error is high or low. If the link probability of error is high, then you better check for errors. And the mode of operation that checks for errors is store and forward, right? So if the frame has an error, I should not forward it, because if I forward it, I will waste bandwidth. Actually, I will waste bandwidth. Okay, but if the probability of error on the link is low, then it's better to send fast, and this way you can conserve the bandwidth. ماشي كده؟ طيب. The destination خد بالك ها, not the switch. I didn't tell you the switch here. The destination network interface card discards any incomplete frames using this frame forwarding method. When does this happen? In cut through or store and forward? That's a bit tricky, but remember, I didn't tell you the switch here. I'm telling you the destination. So this is the switch now, okay? And the switch has an output port, okay, which is connected to the destination. So what I'm telling you now is that, let me stop the, sorry, I forgot to stop the thing. So what I'm telling you now is that the switch will forward the frame and the destination will discard the frame because the frame has errors. If the switch is using store and forward and the frame has an error, will it forward it? Of course not. Okay. So in fact, this is cut through because cut through is the only mode of operation that will forward the frame even though the frame has errors. So if the destination network interface card discards the frame, this means that the frame is incomplete or has some errors and it reaches to the destination. And the only possibility for this is when you use the cut through mode of operation. Because for store and forward, the frame will not be forwarded if it's incomplete or has some errors. The fast switching method, but may produce more errors. Of course, this is cut through. This is clear. ماشي يا شباب. Any questions?